In the last class, we have seen about what is a power amplifier, why power amplifier is required, what are the types of power amplifiers, and performance, how we have to check the performance quantities of power amplifiers, and difference between the power amplifiers as well as voltage amplifiers, and all those things we have seen in the last classes. And today we are going to discuss about the class A power amplifier. And which is this class A power amplifier is classified as two types. One is directly coupled, the another one is transformer coupled. Why directly coupled is, here the load resistance which is directly connected to the collector. That's why which is called a directly coupled class A power amplifier. And today we are going to discuss about the directly coupled class A power amplifier. And all of you draw the circuit diagram. All of you please draw the circuit. I think all of you completed.
Yes, sir.
Okay.
Yes, sir.
Okay. And the circuit is looks like
fixed bias.
Fixed bias circuit. Okay. The class A power amplifier is a very simple fixed bias circuit. But here, whatever the transistor we are using, the transistor is a power transistor. The transistor is a power transistor. And I already mentioned for class A, Q point is at
midpoint.
Midpoint. Okay, to reach to achieve the Q point should be at the midpoint of the load line. We have to adjust the RB value. Here we have to adjust the RB value. And at the same time, RL which is directly connected to the collector. That's why which is called as a directly coupled class A power amplifier. And this is the completely which is called as a series fed directly coupled class A power amplifier. I think all of you understood. Hello.
Yes.
Yes, sir.
Okay. And if you apply the now we are going to see the DC operation. Apply KVL at the output side. Output side means this is. Now tell me. VCC is equal to hello.
ICRL
ICRL
plus
plus VCE.
VCE.
VC.
Okay. From this, I want to find out the collector current. Want to find out collector current. Then what happens? ICRL is equal to VCC minus VCE. So IC is equal to VCC by RL minus VCE by RL. And we can write like this also, minus 1 by RL into VCE plus VCC. So IC is equal to, sorry, VCC into 1 by R. Here the slope M is equal to, can anyone, slope M is equal to minus 1 by RL. Okay, if you consider for the y-axis, y-intercept is 1 by VCC by RL. All of you understood?
Yes,
Yes,
sir.
sir. Yes, sir.
Okay. In the above expression, or let us consider this one as a 1. In equation number 1, VCE is equal to 0. Now tell me the IC is equal to?
VCC by RL, sir.
VCC by RL.
VCC by RL. Okay, we can write as a point 0 comma VCC by RL. All of you understood?
Yes, sir.
Okay. If IC equal to 0,
VCC equal to VCE.
VCC equal to
VCE.
VCE. Now the point is VCC comma 0. I hope all of you understood.
Sure.
Q point is nothing but VCE comma IC. Hello.
Yes, sir.
Okay, with respect to this, we have made that VCE as 0, IC as 0, then we find out. All of you understood?
Yes, sir.
Okay. And now we have to calculate IBQ, IB with respect to the Q point. Now, so where we have to find out the base current? At input side, right?
Yes, sir.
Okay. Now what we have to do? Apply KVL at input side or base emitter loop. BE is nothing but base emitter loop. Now, what is the expression? VCC is equal to the current is IBQ, the resistance is RB. Plus there is a voltage. What voltage it is?
VBE, sir.
VBE. We have to calculate IBQ, then IBQ RB is equal to VCC minus VBE. So IBQ is equal to VCC minus VBE by RB. Okay. If you want, we may consider here as VBE is equal to 0.7 volts. If you substitute here, then what is the expression? VCC minus 0.7 by RB. All of you understood?
Yes, sir.
Yes, sir.
Okay.
Sir.
And this is common emitter configuration, right? Hello.
Yes, sir.
Then beta is equal to, what is beta here? Output current by
IC by IB, sir.
here we are discussing with respect to the Q point. That's why beta is equal to ICQ by IBQ. All of you got my point?
Yes, sir.
Now VCEQ is equal to VCC minus, previously we have already calculated, ICQ RL. All of you understood this step?
Yes, sir.
What is Q point? VCEQ, comma, ICQ. All of you understood?
Yes, sir.
Somebody has to mute herself. They're getting some discussion from the past 5 minutes. Okay. And if we want to measure the DC power input, simply you can call it as PDC is equal to, you know already power is nothing but VI. Hello.
Yes,
Hello. Power is nothing but VI.
Yes.
So here also we have to write as VI, but the current is DC. Okay, here we can write the VDC into IDC, but here VDC is nothing but VCC. IDC is nothing but ICQ. Actually, this VDC is nothing but VCEQ. But VCE is nothing but VCC. We have already calculated earlier. So directly we may write as VCC multiplied by ICQ. All of you understood?
Yes, sir.
Okay.
Yes, sir.
So this is up to this about DC operation. Okay, now we will move on to the AC operation. I hope all of you understood.
Yes, sir.
Okay,
Yes, sir.
okay, thank you. Now we are already mentioning that for class A power amplifiers, Q point is at the midpoint of the load line. Which is at the various IB values. Okay, sorry for the inconvenience. My network has dropped. Okay. Hello. Hello. All of you are there?
Yes, sir.
Yes, sir.
Okay, thank you. And coming to this midpoint, which is a sinusoidal waveform. Okay. Hello.
Yes,
Okay,
sir.
sir.
Okay. Please draw the neatly. All of you, please draw the neatly. The diagram, please draw neatly, which is very important.
Okay, sir.
Because of the tablet, all of you, please draw this diagram. Please make it fast. All of you completed?
Yes, sir.
Okay. Here there are several terms are there. First of all, we will see, we will look into those terms. Okay, here there is the term called V minimum. This is the minimum instantaneous value of collector output voltage. Next, V maximum, which is also maximum instantaneous value of collector output voltage. And the next, I minimum also there. Now tell me about I minimum. I minimum. All of you are there?
Yes, sir.
What is I minimum here? Minimum instantaneous value of minimum
Input voltage.
no minimum instantaneous value of collector output current. IC is, we are drawing the graph in between VCE and IC. Please remember. Hello.
Yes, sir.
I minimum is nothing but minimum instantaneous value of collector output current. Please, all of you, please cheppandi. Imax is nothing but maximum
Maximum
Instantaneous value of
value of
collector
collector
output current. Output current.
And now Vm is equal to
peak value.
peak value. How we can represent the peak to peak value?
BP.
Peak to peak value is nothing but maximum voltage minus minimum voltage. What it is? 2 Vm. Is it right or not?
Yes, sir.
Correct, sir.
Hello.
Yes, sir.
Is it right or wrong?
Right, sir.
Vm is equal to V peak to peak by 2. V peak to peak is nothing but V maximum minus V minimum by 2. What about Im? Just like voltage peak to peak, we have to calculate current peak to peak is nothing but Im. So what is our final value? 2 Im. So Im is equal to hello.
I peak to by 2.
IPP is nothing but I max minus I minimum by 2. Hello?
Yes, sir.
Okay. And this is completely, it is an AC operation. So because of that, all are RMS values. So VRMS is equal to
VM by root 2.
Vm by root 2. What about IRMS is equal to?
IM by root 2.
I come by 2.
Im by root 2. And here we can write VRMS is equal to IRMS multiplied by what is the resistance here at the output end? RL. Vm is equal to Im multiplied by RL. All of you understood?
Yes, sir.
Yes, sir.
Hello.
Yes, sir.
Yes, sir.
Okay. Okay, this is for the AC, VRMS as well as VM. Now, all these are our power amplifiers. So, according to that, we have to calculate the power using RMS values, and we have to calculate the power using peak values, and we have to calculate the power using peak to peak values. Okay, first of all, power using RMS values. Power using RMS values. So means that it is simply PAC. PAC is nothing but here all are RMS values. So obviously which is VRMS multiplied by
IRMS.
IRMS. VRMS is nothing but IRMS multiplied by what is the resistance? RL. Multiplied by IRMS. So the final expression is IRMS square RL. IRMS is nothing but VRMS square by చెప్పండి RL square multiplied by RL. RL cancel. So final value is VRMS square by RL. For our, this is our convenience. You can write like IRMS square multiplied by RL like that only. Or if you want to substitute IRMS value directly here, you will get the same value. Is it right or not?
Yes, sir.
Yes, sir.
IRMS is nothing but VRMS by RL. If you substitute here also, you can get directly VRMS square by RL. Need not to do all the steps. Okay? Okay.
Okay, sir.
Okay, sir.
Next. Using peak values. Using peak values. PAC is equal to VRMS into IRMS. Peak values is nothing but VM comma IM. Okay, VRMS is nothing but
VM by root 2.
VM by root 2. IRMS is nothing but
IM by root 2.
IM by root 2. So finally we will get VM multiplied by IM by 2. Okay, VM is nothing but IM into RL.
IM into RL.
Now we can write this one as Im square RL by 2. Hello.
Yes, sir.
Yes, sir.
Again, Im is nothing but Vm by RL. If you want to expand like that also, we can expand. So, which is Vm square by RL square into 2 multiplied by RL. We will get the Vm square by 2 RL. Is it all of you understood?
Yes, sir.
Yes, sir.
You can substitute the Im value here also. Directly we will get the final expression. If you want to substitute here Vm, Im is nothing but Vm by RL. So Vm by 2 RL. So finally here also you can get Vm square by 2 RL. All of you got my point?
Yes, sir.
Okay. And next, using peak to peak values. Using again, PAC is equal to, already we have obtained Vm Im by 2 in the previous case. Hello?
Yes, sir.
Here the Vm is nothing but Vpp by 2. Im is nothing but Ipp by 2 by 2. Vpp multiplied by Ipp by 8. All of you understood?
Yes, sir.
Yes, sir.
And this Vm Im by 2 we have obtained from the previous using peak values. మళ్ళీ చెప్పాలా ఇక్కడ?
No need, sir.
Okay. So PAC is equal to VPP IPP by 8. Okay. VPP is nothing but V maximum minus V minimum.
By
IPP is nothing but I maximum minus I minimum by 8. Okay, all of you understood these three cases using RMS values, using peak values, using peak to peak values.
Yes, sir. Yes, sir.
Okay,
Yes.
now calculate the efficiency. Efficiency is represented with eta. So PAC by PDC into 100. PAC is nothing but we have already obtained with respect to the peak to peak values. V maximum minus V minimum into I maximum minus I minimum by 8. But PDC is nothing but PDC. PDC is nothing but VCC into ICQ. We have already done previously. DC power input.
yes, sir.
Okay, now what happened? 8 into VCC multiplied by ICQ. All of you understood?
Yes, sir.
Okay, and we
Yes,
will
sir.
calculate the efficiency value in the next class. Okay.
Okay, sir.
Okay, sir.
And we will discuss the another classification of class A power amplifier also in the next class. I think tomorrow we have two classes, right?
B11.
Ah, yes,
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 sir.
yes.
Yes, sir.
Can I close the document?
Yes, sir.
Yes, sir.
Okay. Hope all of you understood. Hope all of you understood.
Yes, sir.
Yes, sir.
Sir.
Yes, sir.
Okay, okay. Thank you. We will discuss the remaining topics in the next class. Okay?
Okay, sir.
Okay, sir.
Okay, thank you. Stay safe. Take care.
Thank you.